you are getting some additional work done. I think this part already you have discussed.
Yes.
1, 2, 3, 4. So TS diagram. Maybe you can remember that I have made a diagram, so I have made a hatch line, correct? This part I have discussed earlier.
Yes, sir.
Okay. So this is the additional work done, you can find it, and overall efficiency is also goes to improved. And one more thing is also very clear in this case. Suppose if it is earlier it was 1 to 2, now it is 1 dash to 2 dash. Now in this case you are getting this extra work done, so efficiency goes to improve, and as well as the dryness fraction is also goes to increase at the end of the turbine. Is it not?
Yes, sir.
Okay.
Yes, sir.
And also you can find that the efficiency of the cycle is also goes to increase because Tm goes to increase actually. Ultimately you can find that mean temperature of heat addition is goes to increase. The second one is by increasing boiler pressure. So in this case, maybe this was earlier the diagram was like this. But if you increase the pressure and keeping the same temperature, superheat temperature, so you can find that. So it was earlier it was 1 to 2, now it is 1 dash to 2 dash, and this pressure was first one is P1, now it is P1 dash. So P1 is the boiler pressure, and now it is increased to P1 dash. So that means P1 dash is greater than P1. So if it is so, in this case you can find that there may be what you can find that this is the amount of work is going to lost, but at the same time so you can find that this is the additional work done we are getting. Okay, but one of the drawback in this case you can find that in this case also efficiency is goes to increase, but one of the problem is that x it is 2 dash, so x2 dash is less than x2. So that means in this case dryness fraction at the end of turbine reduces. Okay, so that is the one of the problem we can find it. So this is also a TS diagram. Please note it down.
Sir, the diagram got hazy a little bit.
Hmm?
Sir, can you redraw the diagram?
Okay, so I'm going to draw it here this side. Okay, so this is the part you can find it. So this is T versus S diagram. So more or less you can find that, but here you can find that the extra work done is coming in this case, and that's why the efficiency is goes to improve. And but here one point is very clear that x2 dash is goes to less, it is reduced than x2. So that means the dryness fraction at the end of turbine, so which is goes to reduce. Okay, so that is the part you can find it in this case. All right, now please note it down.
Right.
Over?
Yes, sir.
Yeah, what's about others?
Yes, sir. Over.
Okay. Okay. So then I'm going to move to the next slide. Number 3 is by reducing the condenser pressure. Okay. So in this case, we can draw it.
Sir, can you once again explain why we are keeping the condensate pressure below the atmospheric pressure?
Why? Yeah, I can explain. So please do this part first, then I shall explain. Okay.
Okay.
P2 is the condenser pressure. Okay. So this is the condenser pressure, and P2 dash. P2 dash is now it is reduced. Okay. So this is reduced. P2 dash now it is. So it is becoming 2 dash. Earlier it was 3. Now it is 3 dash. Now it has become 4 dash. Earlier it was 4. So here also you can find that in this case this much of maybe the additional work you can find it, but at the same time it's also heat loss will also there, but ultimately you can find that the net work done is goes to increase. So that's why in this case the efficiency is goes to increase. And one more point also you should remember, what's about x2 dash is greater than x2 or less than x2?
The same.
Hmm?
Same, sir.
Yes, same.
What, sir?
What's about
About
x2 and x2 dash?
sir, X2 is more.
X2 is more.
Yes, sir.
Okay, so
Because
that means x2 dash is less than x2, correct?
yes, sir. Yes, sir.
So that means in this case dryness fraction at turbine exhaust reduces. So which is definitely not a desirable condition. Okay, so this
Yes.
is the case you can find it. And number 4, by reheating. Now what you can find by increasing P1 or by reducing P2, in both the cases you can find that x2 dash is less than x2, correct? In both the cases the dryness fraction is goes to reduce. So one of the way, so you can write to improve x2 dash, we have to go for reheating. And what is reheating? Reheating is actually heating the steam at reduced pressure. Okay, heating the steam at reduced pressure by using a reheater. So in this case we are using, so reheating is actually heating the steam at reduced pressure by using a reheater. So in this case, one more point also you should remember, in place of single stage turbine, the stages are increased. Okay, so that is very important. So this number of stages are goes to increase in this case. So it is now, instead of single stage, you can go for multi-stage turbine. And on the other hand also, what do we need to do? At a reduced pressure. So we are not getting, or we are not exactly taking out the steam at the pressure of the turbine entry. So at a lower pressure. So we are going to take it out and we have to heat it up. Okay, so that is the purpose. You can find it in the case of the reheating. So which I am going to explain in the next slide. So please note it down first. Then I am going to write it down in the next slide. Instead of the last day, you can write this way also. In place of single stage turbine, number of stages are increased. You can write number of stages are increased. Please note down. Then I shall go to the explanation part. I think you have already learned this one earlier.
Yes, sir.
So shall I move to the next slide?
All right, sir.
Okay. So just it is the recapitulation. Let me draw the flow diagram first. Flow diagram. So this is the boiler. Then what shall we do? Instead of a single stage of turbine, we are using multi-stage of turbines in this case. Just you see the size of the turbine. So this is called the high pressure turbine, HPT. And this is called low pressure turbine. And you can find in low pressure, the size is increased or reduced.
Sir, in the low pressure, it is increased.
Definitely. So because it will be expanded more.
Yes,
Okay.
sir.
So lower the pressure. So what we will do? So at the end of the HP turbine, so one portion of the steam will come out and it will be reheated and it will go to the or inlet of the LP turbine. So this is coming out, this is goes in. So what is this portion is called? So this is known as the reheater, RH. RH stands for reheater. Okay. And this is a boiler actually. So this is coming in, this is goes out. And then the remaining portions are same. So this is called CRH. What is the stands for CRH? Yes, it is known as cold reheat. And this whatever is after heating, it is goes from the reheater and it is entered to the LP turbine. It is known as HRH. HRH stands for HRH is called the hot reheat. Okay, so it is known as the hot reheat. And then the remaining portions are same. Here you can find that the generator is connected and here we are using a condenser. So condenser will be there at the end of the turbine. So this is the condenser. So it is cooling water in, cooling water out. Then we are using a pump, boiler feed pump, and this is called the boiler feed pump and it goes this way. So here what we can do, this we can put this number like this. Maybe this is number 1, this is number 2, this is number 3, this is 4, number 5, and number 6. So if you plot the figure, it will be looking like this. So here one point you should remember, this is entered at a pressure which is P1. So P1 is the pressure, and then whatever is coming at this part, it is called PRH. So which is at reheat pressure it is entering. So this is P1. So P1 is the boiler pressure, and in this case what it will do, it will be expanded, then again it will be heated, and this is the way. So you can find that if it is come here, dryness fractions will be here. You can find that So if you expand this one, suppose if you expand this one, it will come here. Okay, but if you do the reheating, so the dryness fraction is improved in this case. So it is 1, it is 2, it is 3, this is 4. Otherwise it will be 2 dash. If it will be only one stage, no reheating, so it will come here directly. So then this is 4, 5 and 6. And this is the pressures where the reheating is done. That is called PRH. So PRH is the reheat pressure. So you can find that this is the additional work done we are getting here. So definitely in this case there is a chance, but it is not always mandatory. Efficiency goes to increase, but one point is very crucial. That is what? So you can find that, or maybe yes. So yes, here you can instead of this x4 is greater than x2 dash. So that means in this case the quality of steam at turbine exhaust improves. Okay, so that is happened in this case. So this is the TS diagram. Okay.
Yes, sir.
So I think you can tell me in this case this is Q1. This condenser side it is Q2. This is W pump, and here we are getting this is maybe WHP turbine, and this is the WLP turbine, HP turbine and LP turbine. So what is Q1 in the boiler is how much heat is being added in the boiler.
That will be Q of the.
No, it is H1 minus
H6.
H6 plus reheater is also there.
H3 minus H2.
Minus H3 minus H2. All right.
Yeah.
So what is Q2? Condenser part. So this is Q1.
H4 minus H5.
This is Q2. Q2 is equal to H4 minus H5.
H5.
And what is WT? So WT is WT means high pressure turbine
HPF.
plus
Yeah.
W low pressure turbine. So high pressure turbine, what is the value? It is H1 minus H2 plus H3 minus H4. Okay. Now what is the last part? What is the WP? Pump work? H6 minus H5. Okay. So based on this, one can easily find out the efficiency of the Rankine cycle. That should be equal to 1 minus Q2 by Q1. Either you can use this formula, or maybe you can write down WT minus WP by Q1. Please note it down. I think it is clear. Or is there any confusion in understanding? You can tell me. I can once again.
WT, what you wrote?
Which one?
WT.
W turbines, high pressure turbine. It is HPT.
Okay, sir. Okay, sir, got it. LPT.
Yeah. It's HPT plus WLPT. Here one point is very crucial. What is that point? What is reheat pressure?
Yes, sir.
What is the reheat pressure generally?
Sir, it is generally the GP of. Sir.
What is the reheat pressure? Yes.
Symmetric mean of P1 and the condenser pressure.
No, not that way. Yes, any other opinion?
Or sir, 20 to 30% of it.
Yeah, somewhere, yes.
The 20 to 30% of the boiler pressure.
Not exactly 22. It is coming nearly 25%. Okay.
Okay.
20 to 25%. Okay. So I think shall I move to the next slide?
Yes, sir.
Okay. Now,
Yes, sir.
in the reheating, there are three possibilities. Reheating, I will discuss about the regarding reheat pressure. Now, what are the possibilities? So possibility number one. So it is going to reheat. It is come down, but still it is in which zone?
Superheated zone.
Yes. So this is one of the way. So one, it will reheat. So here you can find that if you go through this way, you can find that pressure is increased. So that means in this case, 1, 2, 3, 4, 5, and 6. If we do this way, so here P reheat. So in this case, point number 2, it is in which zone? It is in the superheated zone. All right. So this is the first
Yes.
possibility. So that means in this case, if it is coming under the superheated zone, so in that case, maybe the condition, maybe in this case, the steam condition may be mentioned. All right. So this is possibility number one. What is the second possibility? Second possibility is there.
It may touch the
Yes,
line of
it is exactly the dry saturated. Dry saturated
right.
means it is touching the line. Then it
Yes,
is
sir.
goes to expand, and then you can find that this is the way the figure may come. So this is second possibility. It is 1, 2, 2 means it is exactly touching here. 3, 4, 5, and 6. So that means in this case you can write this way. So it is, in this case, point number 2, it is what? Dry
Irritated.
saturated. And if it is dry saturated, no need to mention, no need to mention about the pRH. We can calculate it. How can we calculate? It is very easy to calculate. We can easily calculate this one. Because already you know that
Yes.
S1 is equal to S2.
Yes, sir.
Alright.
Yes, sir.
So
Yes, sir.
S1 is equal to S2 means, so we have to find out S2. So corresponding P saturated pressure, we have to find it out because it is equal to what? SG. SG corresponding to which P saturation?
Yes, sir.
Alright. So that we have to find it out. So based on this, we can easily find it out. So there is no need to separately mention about that what is the reheat pressure. And there may be one more possibility. What's the third possibility? Anyone?
Inside the vapor dome.
Yes. So that means it is, as I have mentioned, it is a dry saturated. This is superheated, and it should be wet steam.
Yes, sir.
So that may be the other possibility. So it will be expanded. Now it is entered inside. Then it is going to expand. Okay. And
Yes,
then
sir.
you can find that it is coming here. So this is one. Now here this pressure we have to find out. It is P reheat pressure. 1, 2, 3, 4. Then it is 5, 6. So in this case, point number 2, it is in which? It is wet steam. So here also we need the steam condition is necessary to be known to determine PRH, or maybe PRH is given. All right.
Yes,
So
sir.
these conditions you have to find it out. So these are the 3 possibilities you can find it. Now here I am going to write it down. One more assumptions. If P, you note it down here. Better to erase first. I'll use it. If PRH is not given, consider PRH is equal to 1/3 to 1/4 of P1. What is P1?
The boiler pressure.
Yes, it is a boiler pressure. So please note it down, this assumption. 1/3 to 1/4 of P1. So that is the constant, if nothing is mentioned. So this is the thumb rule.
All right, sir.
Is it clear, everyone? Or is there any confusion? Yes, others?
Sir,
Okay.
when this reheat pressure will be 1/3 to 1/4, then the efficiency would surely increase, right? Because
Yeah,
it is the
1/3 to 1/4 means it is generally, this is the thumb rule, we have seen it. And what we can find that if you go for this, if you suppose if it is 1/3 or 1/4, if it is 1/4 means it may come inside little bit. And if it is 1/3 means it is maybe coming to the superheated zone.
okay, okay, all right.
All right. So then it is now your case, if it is based on the condition is given, suppose in the problem directly reheated pressure is given. So there is no doubt, no problem to find it out. If suppose it is mentioned very clearly, it is a dry saturated, like the second case. So you can easily determine what is the reheat pressure. In this case, one can easily find out what is the PRH. So because S1 is equal to S2 and S2 is equal to actually the SG, because this
Yes,
is
sir.
SG. So SG at which
Yes.
pressure it is same as S1. So that value will be the that pressure you have to consider.
Yes, sir. Yes, sir. Got it.
Okay. I think I have mentioned, I have a little bit in details, I have mentioned all this. And one more point also, like this. See, in my case, I have mentioned, see, 1 and 3 are almost on the same temperature. All right.
Yes.
So
Yes, sir.
it is generally we are trying to maintain the same temperature as the inlet temperature, but it is not always, it is not essentially that S1 should be equal to S3. In some of the cases, it may be more also, or in some cases, it may be lesser also. So it is definitely, it is a trade-off of the company who is manufacturing the reheater, or maybe who is fabricating the boiler. So this is its own discretion. Maybe they have calculated and they have assumed their own value, and based on this, they are fabricated. So that's why in general conditions, we are trying to make T1 is equal to T3, but it is not always that T1 should be equal to T3. It is depending on, it may be T3 may be little bit higher than T1, you can find it, or maybe sometimes it may be little bit lower than T1 also. Both are possible. Okay, is it fine now?
Yes. Yes, sir.
Okay, you can note it down somewhere.
One minute, I am copying.
Yeah, yes, sure. See, I am giving more weightage in this part because I want that this part should be very clear to you. Because once it is very clear, then no problem, you can, means any kind of problems you can sort it out, you can solve it.
Okay, sir.
Okay. So I think we can go to the next part of our discussion. Now in this case, last one is called, I think this should be fourth one, huh? Or fifth. 1, 2, 3, 4, I think. 1, 2, 3, 4, 5, I think. Yes. It is regeneration because it is coming under the increasing the value of Tm. How to increase the value of mean temperature of heat addition. So that is the regeneration. And I think you know that in the regeneration, you can remember that we are using a hollow turbine, correct? This is what I have discussed in the class, in your thermodynamics classes. So instead of a conventional turbine, I am using a hollow turbine. Hollow turbine means in this case, it is having concentric surfaces are there. So suppose this is the turbine surface. Okay. So here is also, so here the blades are there. So here in between, the spaces will be created. So in this space, we are trying to send the steam. Okay. Or maybe the water. So this will pass through this. So it is a hollow turbine. So this is a hollow turbine. It is connected with the generator. You can find that this is connected with a condenser. And what it will do, it will go back, correct? So in this case, it will be goes back. It will go here, and in this case, it will come out, and it will go here. So this is the boiler. This is this number. You can find that this is number 2. Actually, it should be 2, but it is becoming 2 dash. I'll explain. I think you have already know it. So now it is point number 3. This is point number 1. This is 4. And this is considering that it should be equal to it is 4 dash. So this point is 2 dash. So this is TS diagram. So this is 1. It's supposed to be 2, but it's becoming 2 dash. It's 3, 4, and 4 dash. Okay. So just you match it. So here this is Q1. So Q1 is here. This is Q2. So Q2 will be here. W turbine, WT. So WT will be here. And this side is WP. This side is WP. Do you remember this one?
Yes, sir.
Yes.
So what happened in this case? Can anyone tell me?
Sir, there is no change in work output basically.
Why? Turbine work should be same.
Turbine work is same, but overall whatever has been produced
No,
will
turbine work will not be same in this case. Yes. Okay, let me explain here. What is happening in this case? So I am taking a turbine. It's not a simple turbine. It is a hollow turbine. So that means whatever turbine you have seen it, over this suppose there is one more casing is also there. And in between the fluid can move. So what it will do, first at the conventional way the steam is entered here, then it will come out and it goes to the condenser. So heat rejection will take place. Then with the help of the boiler feed pump, we are sending the water, feed water. Actually directly it will go back to the boiler. So it is a conventional Aitken cycle. But what we did in this case, now why, first of all question is that why regeneration? Now why the regeneration is coming into the picture? Now here you can find that in the power plant, the majority of the heat loss is taking place where? You know where it is taking place? So majority of the heat loss takes place in the condenser. Alright. So in regeneration, we are trying to reduce this heat loss and increase the feed water temperature before entering the boiler. Okay, so it is, you should remember the majority of the heat loss is taking place in the condenser. So in regeneration, what we are trying to do, so the heat loss in the condenser we are trying to minimize, and whatever heat loss or we are getting this heat, we are trying to add this heat into the feed water, whatever is going back to the boiler. If we can increase the temperature, whatever is entered into the boiler, so obviously what is the advantage there? So advantage wise you can find that less quantity of heat is required in this case to convert water into the steam. Alright, so that is the advantage you can find in this case. Clear?
please repeat once.
I mean to say in this case, you can find one point is very clear. So first let me explain this one, then it will be very clear. So at point number 1, the steam is entered. Now if this turbine is not a hollow turbine, it is a simple turbine. So what's the process? It will be 1 to 2. It should be isentropic expansion in the turbine. Correct. But it is not happening in this case. Why it is not happening? Because what we are trying to do, whatever may be the feed water coming out from the condenser. So this is the condenser. So whatever may be the feed water is coming out at point number 3, we are not directly send it back to the boiler. Instead of this, we are trying to take out some of the heat from the turbine. So we are sending it through heat. So obviously what it will do, the feed water temperature will be increased because some amount of the heat from the turbine it will be taken by the feed water and its temperature will be increased. And at point number 4, so whatever maybe the feed is goes out, the temperature will be increased. So that means you can find that. So 3 to 4, it is the conventional way after the pump. So 4 to 1, the heat addition will take place. But at this condition, what you can find? Because whatever the heat will be lost by the turbine, so that will increase the feed water temperature from 4 to 4 dash. So now what is the heat? What is the Q1 right now? What is the Q1? Q1 is actually H1 minus H4. But now, in this case, you can find that heat will be from the turbine, you are getting the heat and the value 4 is changed to 4 dash. So what should be the Q1?
H1 minus 4 dash.
H1 minus H4 dash.
Yes, sir. Yes.
H1 minus H4 dash. It is not H1 minus H4. So that means in this case, the quantity of heat is reduced or not? To convert water into steam?
Yes, sir. Yes, sir.
Is it reduced? But here, one point you should remember in this case, I am going to write it down. You have to explain. Boiler size is increased. Why? Because we are telling one side the heat input to convert water into steam is reduced, but the boiler size is increased. So what for?
Inlet pressure for boiler is more.
Now there is no change in the boiler pressure. Same thing is there.
Sir,
Actually, if you really find it out, Q1 instead of kilojoule per kg, if you make it kilojoule, so what is there? So it is mass flow rate into H1 minus H4 dash. So for the same Q1, because heat addition is same, but if H1 minus H4 dash, if it is reduced, so what's about the M?
it must increase.
It must be increased. So increase means what? So more quantity of steam has to be
Pass through.
produced.
Yes, sir.
You have to produce more steam. So that's why the boiler size will be more. Is it clear?
Yes, sir.
Maybe the heat addition to convert the water into steam is reduced. Per unit kg it will be reduced. But the mass flow rate has to be increased, because in this case you can find that because if the total quantity of the heat is same, so obviously in this case the steam production rate has to be increased. So that's why boiler size
Yes.
has to be increased. Is it clear or not?
Yes, sir.
Okay. Now one point is clear. Now here you can find that. Now whenever it is passing through this, so obviously in the turbine there will be some heat loss. So due to this
Yes,
heat loss, this is not becoming isentropic. So what it will do, instead of 2, it is coming where?
2 dash.
2 dash. So that means in this case, what is the process? It is 1 to 2 dash. So the process is not 1 to 2, it is 1 to 2 dash. So that means whatever maybe the heat loss you can find in the shaded area, same quantity of heat is being added where? This 4, this point number 4 is this amount of heat it is gaining and it is converting into 4 dash.
Yes, sir.
All right. So now here you tell me what is the Q2. So how much is the condenser heat loss?
Sir, it will be H2 minus.
Why H2? Now it is process is not 1 2, it is 1 2 dash.
H2 dash, sir. H2 dash minus H3.
So please note it down here. One point you may missed is actually. So you can write this way. In turbine, what is the process? It is process is it should be process 1 to 2 dash. So please note it down. Okay, in turbine the process is 1 to 2 dash, not 1 to 2. So that means what should be the Q2? It is H2 dash minus H3. Now it is 2 dash to 3.
Yes,
is
sir.
it not?
Yes, sir.
So what's about the condenser size then?
Sir, it should decrease.
Yes. So here you please note it down here. So here I am writing it here. Q2 is equal to H2 dash minus H3, because the turbine expansion takes place in process 1 to 2 dash, not 1 to 2. All right. So if it is reduced, so obviously you can find that Q2 is reduced, this value is reduced. So that's why you can find that the condenser size is reduced. Okay. So boiler size is increased, but the condenser size is reduced in this case. And one more thing is also, now you tell me in this case, now the heat addition. So what is the turbine work? Because you are telling that it should be same. So what should be the turbine work?
Sir, here H1 minus H2 dash.
No. So I am writing this way. So just you consider you just apply the steady flow energy equation in turbine. So that means what we will write? Total energy in is equal to total energy out. So what is coming in?
Yes, sir.
So you can suppose in this case what is coming in. So H1 is entered. Okay. So WT is outside. So minus WT. Okay. Now what is entered again?
H2 dash. H2 dash is leaving.
Yes. So what we can write in this case? H1
H2
is
dash
entered. Yes.
H2 dash plus.
So whatever is entered, first of all, you write it one side, whatever is entered. So entered is what? You can write this way also. So you can find that H1 is entered. So minus W2. Now what else we can write down? So in this case, you can find which is H2 dash is goes out or entered.
Sir, that will be at the final state. So
Now what is it entering in the turbine or goes out? H2 dash.
is out, sir.
So H2
Goes
dash
out.
is minus sign
Yes, sir.
plus whatever is entered. H4 is entered. H4 is entered.
Yes, sir. Yes,
Plus
sir.
sign, and whatever
Yes.
goes out. H4 dash is what? Plus or minus?
Sir, minus H4 dash.
So minus H4 dash. That should be equal to 0. So that means what will be the WT? WT will be H1 minus H2 dash. It is not simply H1 minus H2 dash. It will be minus of H4 dash minus H4. So that will be the turbine work done. Please note it down. It is not simply H1 minus H2 dash.
Yes.
So that means in this case, actually turbine work done is same or it is reduced?
It is reduced.
See, here also I can explain once again. Boiler size, why it is being increased? Because you can find that the work done is less. But you have to,
Yes, sir.
what do you have to do? You have to produce the same work done. So what do you need to do at that stage? Mass flow rate
Sir,
of the
we
steam
have
has to be what?
increased.
It has to be increased. You can explain this way also. All right.
Yes, sir. All right.
What's about others? Are you getting or there is a confusion? I'm creating more confusion in understanding.
No,
No,
sir.
sir,
Yes.
all right, all right.
Is it clear or not? Because I cannot get any response. So I don't understand that whether you are understanding it or is there any doubt is in your mind. Maybe you can feel that sir is making it more complicated. I'm trying to make you clear as much as possible from my side. But if you don't understand, you tell me, then I may try to explain in some other way. Is it clear or not clear?
Clear, sir.
Okay, fine. Then
Yes,
it's
sir,
no
yes.
problem. Okay, it's fine. Now, in this case, I think I can erase this bottom portion. Now, what's about WP pump work?
Sir, pump work.
It
Pump work.
will no change. No change will be there. It is H4 minus H3.
Yes, sir. Yes.
Okay, please note it down. Now, I want to erase this portion here. So I think you have done this one. Shall I erase?
Yes, sir.
Okay. Now, in this case, it is very clear that if you see the diagram, it is very clear that the heat loss, so the slope of line 1 to 2 dash is identical, and 4 and 4 dash to 3 are identical. So that's why the hedge line I have put it. So here, that's why you can write it down. So the area, you can put it this way also. Just to expand this one here, you can just extend this line here. You can write it. This is A, B, C, and D. So we can write it down. Area 1D C 2 dash is equal to area 4 dash 3, sorry, 4 dash B, 4 dash B A 4. All right, so please note it down. So these both the areas are same. Basically, what I mean to say that this total area and this total area are same. So here this complete area. This complete area are same. So here we can write down, already we know that what is Q1. Q1 is equal to H1 minus H4 dash. So we can write it down this way also. That should be equal to what? Suppose I am taking this temperature is equal to T1, because this 1 to 4 dash to 1 the temperature is constant. Similarly 2 to 3 also the temperature is constant. So I am taking it is equal to T2. So it should be equal to T1 into S1 minus S4 dash. Similarly Q2, that should be equal to H2 dash minus H3. That should be equal to T2 into S2 dash minus S3. Okay. Now as this area are same, so what we can write here? So here you can write this way also, because you can find the S4 dash minus S3. That should be equal to S1 minus S2 dash. So in this case we can write this way also, S1 minus S4 dash. That should be equal to S2 dash minus S3. So these correlations we can find it. Now if the efficiency of the cycle, regenerative cycle, is equal to 1 minus Q2 by Q1. 1 minus Q2. What is Q2? It is T2 into S2 dash minus S3 divided by T1 into, it should be equal to S1 minus S4 dash. Already we know that S1 minus S4 dash is equal to S2 dash minus S3. So we can cancel this one, and it is becoming 1 minus T2 by T1. So that should be equal to regenerative cycle efficiency. And it is equal to what?
The Rankine cycle.
It is same as the Rankine cycle. Not Rankine, this Carnot cycle.
Sorry, Carnot cycle.
Carnot cycle efficiency. Okay. So it is same as the Carnot cycle efficiency. So I think I better to write it somewhere here. I will erase this portion and I can write it in a fresh fashion. So here it may be confusing. So here I can write here. So efficiency of the regenerative cycle, that should be equal to 1 minus T2 by T1. That should be equal to T of Carnot cycle. So that's why many times we can say, we can write this way: regeneration is the attempt to convert the Rankine cycle into Carnot cycle. So regeneration, I am repeating, regeneration is the attempt to convert the Rankine cycle into Carnot cycle. Okay, so please note it down. This point is very important. So please note it down. So it is to convert the Rankine cycle into the Carnot cycle. That is very important. Or else what we can say also, in other way also we can write this same thing in little bit different fashion. We can write this way also. So by regeneration we can Carnotize the Rankine cycle.
Yes, sir.
Can I write like this? So by regeneration I can Carnotize the Rankine cycle, or we can Carnotize the Rankine cycle.
Yes, sir.
So do we get the maximum efficiency in?
Yes. So that means, as we all know that, I made a mistake. What is the mistake? It is not T. It should be efficiency. Please make the changes. Efficiency Carnot cycle, not T of Carnot cycle. It is efficiency of Carnot cycle. Yes, you are very true. correctly is mentioned that Carnot cycle is always giving us the highest efficiency. So that means by regeneration. So by regeneration, we can make an attempt to make the highest efficiency by any heat engine. So heat engine, as you all know, that the Carnot cycle is the heat engine which gives us the maximum efficiency. So definitely the Rankine cycle, if we can do it, the regeneration process. So we are trying to make the Rankine cycle into the Carnot cycle. That means we are trying to get the highest efficiency. All right.
Yes, sir.
Okay. So shall I move to the next part? Now the question is that I think these all parts I have already mentioned. Those who have studied, you can easily understand that I am repeating the same thing, but those who have forgot actually. So for them, maybe it will be the recapitulations, so that there should not be any confusions, or maybe there should not be any doubts. Maybe some of the portions you may missed. Okay, so which I am trying to once again remembering you. So shall I move to the next slide? Shall I move?
Yes, sir.
Now this is very clear that why this particular attempt is not possible. So this cycle, so or maybe this cycle means the way whatever this cycle is not possible in practice. So why it is not possible? So I am going to write it down. So note it down. It is so reversible heat transfer cannot be, so it is cannot be possible in finite time. So reversible heat transfer cannot be possible in finite time frame. Number two, in turbine, heat exchange is not possible. So that means the turbine and as well as the heat exchanger, both the work cannot be done together. So that is not possible. And number three, what you can find, if you really go to the last figure, so what you can find, what's about point number 2 dash?
Sir,
Dry
its
inspection? Yes.
dryness is reduced.
Yes. So that means you can find in this case, you can write it down, the moisture content of the steam in on the steam. So the moisture content in the steam of the steam at turbine exhaust will be high. Okay. So that's why we cannot go for this particular way. So what we can do? So what is the practical aspect of regenerative Rankine cycle? So answer is by using feed water heaters. So we are using or by extracting by using feed water heaters and extract steam from the turbine. Okay, so I shall explain that what is the feed water heaters. Maybe we can write it in the bracket FWH, feed water heater. Written?
Yes, sir.
So what is the practical regenerative Rankine cycle? So what we'll do, we are using the feed water heater, already we know it. So the feed water heater, so here by using feed water heaters, so we just call FWHS. So this feed water heater may be classified into two ways. One is called open type of feed water heater, or sometimes it is called the direct contact type of feed water heater, and another is called the closed feed water heaters, or maybe it is called a closed one, or maybe non-contact type of feed water heaters. So it is direct contact, or it is called indirect contact type of feed water heater. Here is also one more name is also there. I think you can remember. What is it is called? What it is called?
Aerator. Yes, sir.
Deaerator. What is the function of the deaerator?
Sir, it reduces air content.
So first of all, it removes air, or better to say that more specifically, or oxygen from feed water, okay. And number two, increase the temperature of feed water by direct mixing with steam extracted from steam turbine. Okay. First one, it removes air or the oxygen from the feed water, and increase the temperature of the feed water by direct mixing with steam extracted from the steam turbine. So please stop me whenever the time will be at 5. You are having a class at 5, I think. You have class?
Yes, sir. Yes, sir.
Okay. What is the time right now?
Sir, 52 past.
4:52.
1:52. Okay. Okay. Some more times I'll take just 5 minutes more. I think if those who can remember that at this time, maybe during the classes of thermodynamics, I mentioned that from where the air is coming in the feed water. So that is the first question. And the second question is that if the air is at all coming in, it is entered, then what should be the difficulty? What is the problem? So how the air is coming in? Yes, anyone? From where the air is coming in? Yes.
Sir, from condenser.
Yes. How?
Because sir, we are creating a negative pressure in the condenser. So
some of you have raised this question. I forgot actually. Yeah, who has raised this question?
me, sir.
Okay, okay. What is your doubt?
Sir, my doubt was that, sir, as we are decreasing the pressure in the condenser, means negative pressure we are generating. So the sir, for what reason? To decrease the saturation temperature of the water, so that
No,
more.
no. No, it is not that way, because if you really remember that, I think, let me draw this way. So this is the heat exchanger, correct? So there is a condenser is a heat exchanger. So you can find that this is the heat exchanger, this is the condenser. So here you can find that the cooling water is coming in, and this is the cooling water goes out. And what is this coming? It is the steam from where? Steam from turbine is coming in. Now what it will do in this case, if you really plot this curve, so it will be looking like this. So maybe you can take this is it is the cooling water in, and this is the cooling water out. And here you can write this way. This is the hot water in, and this is the hot water out. Okay. Now you can remember that what is the cooling water in? What's the temperature I mentioned in India? Average temperature?
33
degrees Celsius. Now this temperature rise, cooling water will increase the temperature because the heat lost by the steam, or not hot water. You just, I think I mentioned. So steam, it is steam in. So here it is called condensate. Condensate out. So here you can write down it is the steam from turbine, which is being entered, and here it is the condensate out. So here you can find that there is a temperature rise of cooling water by 5 degrees Celsius temperature. So if 5 degree temperature rise is there, then what is the cooling water outlet temperature?
38.
38 degrees Celsius temperature. Now here, this is also a temperature difference, because see, it is steam is entered and steam is going out. So there should be a temperature difference, because there is a heat exchanger will be there. And this temperature difference is 5 degrees Celsius. Then at which temperature the steam is entering? What is the inlet temperature of the steam? Means what is the exit temperature of the steam from the turbine? At which temperature?
43.
43. At which at the condenser it is entering. So that means this is 43 degrees Celsius temperature it is entering. So what is the saturation pressure?
Sir, it was around
Saturation pressure corresponding to 43 degrees Celsius temperature is nearly what? 8.9, nearly 8 or 9. Okay, in between of 7 to 8. So nearly 8 kilopascal. 8 kilopascal means, which is equivalent to 0.8 bar. Alright. So atmospheric condition is how much? Atmospheric pressure 1.013 bar. Now what's about this pressure? So 0.8 bar pressure is less than
vacuum
atmospheric.
pressure.
So what is this pressure?
vacuum pressure.
It is negative pressure, vacuum or negative pressure.
Yes, sir.
Is it clear?
Yes, sir.
Okay. Now here this question is coming because already you know that there is a negative pressure is there. So if the negative pressure is there, so there is a chance that in this case, if there is any leakage, is there air will ingress? Air will
Yes,
come,
sir.
and
Yes,
air
sir.
will come through what? Cooling water. From the cooling water, if there is any leakage in between cooling water lines somewhere, so air and steam will mix together.
Yes, sir. Yes,
So
sir.
you can note it down. So if there is any leakage in cooling water line, then the air along with cooling water mixed with the steam inside the condenser. Alright?
Yes, sir.
If the steam is entered, then what is the problem? If air is entered, what is the problem? So you can write down at high temperature in the heat exchangers, like superheater, reheater, okay, or maybe in the superheater, reheater, or what you can say then superheater, heater, evaporator coils, or maybe okay, reheaters. You can write this one, reheater coils, the oxidation of coil materials take place. Means this coil is having some material, maybe it is molybdenum, maybe the vanadium, okay, maybe chromium. So this will react with oxygen, and it is forming what? Like iron. If it is going to react, it is forming ferric oxide or ferrous oxide. It is like a, you know that the rust is going to produce, how it is going to produce. So the similarly the oxidation will take place, means what? What it will do?
Yes,
So that means in this case, the you can find that there is a deposition of metals inside the coil take place. Alright. So if suppose within the coil, if suppose it will be deposited, so what it will do? It's like our vein. Suppose you know that if there is any problem is there in our artery or in our blood vein, so in this case, suppose the cholesterol is deposited, what it will do? The possibility of heart attack will be more. So similarly, in this case also, suppose first of all the heat is not being properly, it will be propagated because there will be some insulation will be there because it is acting as the insulation. It is a metal deposit.
yes, sir.
So that means heat will not be transferred properly. A second thing is that the unnecessary pressure will be grown. So there is a chances of failure. Rupture will be there.
Yes, sir.
So to overcome this problem, you have to go for the DARSN. So air has to be removed. So I have to stop here. I think it is about to be 5. All right. So just wait. Is there any confusion in between? You can ask me. Otherwise, I just wait for a few minutes. I am going to take the attendance.